Okay, now we're going to prove this situation, and I can only use the product rule and the identity function. Okay, so I want to prove that this is true. Well, by induction, I have to show n equals 1. So that means x to the n, x to the 1 equals 1 times the derivative of x to the 1 is equal to 1 times x to the 1 minus 1, which simplifies to 1. That's by formula. Now, I also know if I take the derivative of x to the power 1 by my rules, that this I know is 1. Therefore, true for n equal to 1. My next step is to show it's true for n equal k. I'm going to assume true, meaning that the derivative of x to the k dx is equal to kx to the x minus 1. That's assumed true. Now I have to show true for n equal to k plus 1. If I want to show it's true for n equal k plus 1, I want to show that dx to the k plus 1 dx equals k plus 1 x to the minus 1 to the k. This is by the formula. I want to show that this is true. Okay, so what I do then is I want to start with d to the k plus 1 dx is the same thing as find the derivative of dx times d to the k over dx. Well, here is my product rule. So by my product rule, I can say that the derivative of x is 1 times x to the k plus x times, well, the derivative of k is my assumption, is k times x to the k minus 1. All right, let's put things together. I get x to the k. Well, x times x to the k minus 1 is equal to x to the k. And so if I pull out a factor of x to the k, I get 1 plus k, which is what I'm looking for. So, since pk is true, implies pk plus 1 is true. So, since n equal to 1 is true, Pn is true for n being an integer that's positive, I think is what my restriction was. All positive integers, yes. Is true for that by mathematical induction.